Alright everybody, welcome back. We are going to start our Unit 7 notes. Hopefully everybody had a wonderful Thanksgiving break. I know that myself and Coach English and Ms. DeLong are super happy to have all of you back. So, we are going to jump into Unit 7, which is all chemical quantities, okay? So, you'll notice again, we put on here a calendar that outlines basically everything that you can expect for this unit. We'll begin this after our test. You'll notice you have a quiz, okay, the 9th and 10th. And also I want to add in something so you can look forward to it. We will be doing a fun outdoor lab on this day. So depending on the weather, make sure you dress appropriately. Alright, so let's go ahead and jump in. So we are, day 1, dimensional analysis. We're going to be talking about and learning how to convert grams to moles, or you can do moles to grams. So why we do this, okay? So if we're given a value in grams of a particular either element or a particular compound, we want to figure out how many moles there are. Well, we can't just look at our periodic table and say, oh, there's, so-and-so amount of moles in, I don't know, chromium. It doesn't tell us that. All that we can see on our periodic table is mass. And so we're going to be bringing back how to calculate the molar mass. And then we're also going to do some dimensional analysis that we did from the beginning of the year. So we're going to be taking some of those things that we learned at the beginning and putting them into what we're doing now. But before we get started on this actual first example, what I wanted to draw, and you'll be doing this with your class, is I wanted to have you guys draw what we like to call, it could be, it's going to be called a bunch of things, but basically this is going to be a tool to help you figure out what you need to do to convert from one unit to the next, okay? So what I'm going to start here is your mole goes in the middle, okay? So today we're just going to be focusing on grams to moles, but later on we're going to be talking about particles too. So just know that in the middle you always have your mole. So if you need to go from one value to the other, you have to go through the moles before you get to the other. So over here we have grams, okay? That's your mass, okay? So right here we have our molar mass, and that unit is grams per mole. So what that means is if we're given a mass value, okay, that you have to calculate the molar mass in order to get your mole. And it's vice versa. If you have your moles, then you still have to have your molar mass to get to grams. Over here, we have particles, okay? And here, the conversion we're going to use is Avogadro's number, which you can find on the inside of your periodic table. Now, this could also, okay, you have particles per mole. This could also be atoms. This could also be molecules, and it also can be formula units, okay? So there is a lot of things that it could be, but today we're just strictly focusing on grams and moles. Alright, so let's jump into some problems, and I will be referring back to this table. Alright. So our first example says, how many moles, so that's what we're trying to find, are there in 100 grams of aluminum sulfide? So this 100 grams, that is our given. We're trying to find moles. So here's where you're going to have to pull out and figure out what aluminum sulfide is. That was all Unit 6. That was formulas and naming. So hopefully we can remember how we do that. So I'm going to look at aluminum. I'm going to write aluminum right out here. Aluminum, we know, has a charge of +3. Okay, sulfite is one of our polyatomic ions, and we can find it right here. Okay, SO3 with a charge of -2. So we have SO3 with a charge of -2. So what I do here, okay, is I'm going to swap my charges. Now, I will need parentheses for my polyatomic ion because I do have more than one. So when I write this, I have Al2, open parentheses, SO3, 3. Okay? That is my formula. Now, moving on to my molar mass. So, hopefully we remember how to calculate molar mass, but if we don't, then here's a little refresher. So when we calculate the molar mass, we're having to figure out the mass of every single element that we have. So, what I'm going to do out here is I'm going to write, I have aluminum, okay? I have sulfur, and I also have oxygen. Now, I always work from right to left to figure out how many I have of each, because when we get to where there's parentheses, you have to multiply what you have in there. So I'm going to start over here. I have a 3 outside and I have parentheses. Oxygen inside the parentheses has 3. But on the outside I have a 3, so I have to do 3 times 3, which gives me 9. Sulfur tells me it just has 1, but I also have sulfur inside the parentheses, which means I really have 3. Aluminum just has 2. I don't do anything with this 3 because aluminum is not inside the parentheses, so I just have 2 aluminum. Now, what I need to do next is I need to figure out what my mass is of each of them based on the periodic table. So I'm going to go over here and I'm going to look for aluminum. It tells me it is the average atomic mass of aluminum is 26.98. For sulfur, it tells me that atomic mass is 32.06. And for oxygen, it's 16. All right. So I have all of these, and now I just need to multiply to see what my individual for each element is. So 2 times 26.98, I get 53.96 grams. Sulfur, 3 times 32.06, I get 96.18 grams. For oxygen, 9 times 16, I get 144 grams. Alright, so I have my mass for each individual one. Now I have to take, for aluminum, sulfur, and oxygen, and I add all of these up. So I'm going to add 53.96 plus 96.18 plus 144. And my grand total is 294.14 grams. Alright. And I know it might be a little tedious, but you have to do it to solve these problems. So, again, I have my molar mass, and I'm looking for moles. So if I look back here, okay, at my diagram, we don't know our mole, but we have grams. We were given 100 grams. So in order to go from grams to moles, I have to use that molar mass that I just calculated, okay? So what I will do is, when we're setting up dimensional analysis, I'm going to take my given, which is 100 grams, and I'm going to write it exactly how I see it. So 100 grams of aluminum sulfite, but I will add that formula, okay? I'm going to draw my train track, okay? I have grams right here. So in order to cancel out grams to get moles, I have to put grams down here also. Well, what gram value am I going to use, Miss Scoggin? The one you just calculated up here. So I'm going to take that 294.14 grams of aluminum sulfite, and I'll put it down here. Now, molar mass, okay, 1 mole is always equal to the molar mass. So, 1 mole of Al2SO3, okay? Close parentheses. Now, I'm going to ask myself, am I done? I am, because my desired unit that I'm trying to get is moles, and my mole value is up at the top. So I can cross out my units that I don't have or that I cancel out, okay, because grams of aluminum sulfite and grams of aluminum sulfite will cancel out. Now, to solve this, I'm going to multiply. Nope, you don't multiply. Why, Miss Goggin? Because this 100 is above this 294.14. You have to divide. You divide what is on top from the bottom. Okay? And we will get to a point where there's going to be more numbers. Okay? But we're not there yet. So I'm going to take 100, and you need to type exactly what you have in your calculator or what you have on your paper onto your calculator. Divided by 294.14. Okay. I'm going to write exactly what I see. Okay? That is my mole value. Okay? Now, am I done? Heck no. Because we have to do proper sig figs. This 100.0 grams up here tells me I have 4 sig figs. I don't have 4 sig figs here. So my final answer, with correct units, would be 0.3400 moles of Al2SO3. All right. Here we go. Moving on. The next question, okay, asks how many grams, that's what we're looking for, how many grams of water is in 1.34 moles of water. Now, hopefully we all know what water is with the formula. H2O. Okay? So I'm going to take that and put my formula, H2O. Now, I need to find my molar mass. So I have hydrogen and I have oxygen. How many hydrogen do I have? I have 2. The molar mass for hydrogen is the atomic mass is 1.01. We have 1 oxygen times that atomic mass, which is 16. Okay? When I do, and again, you can probably do this in your head, but just to visualize, 2 times 1.01, that gives me 2.02. So I'm going to take these and I'm going to add them, okay? And I get 18.02 grams. So I have my molar mass, and I'm trying to find grams. So I'm going to take my given, which is this mole value, okay? And I will take 1.34 moles of H2O. Draw my train track. Now, I'm trying to figure out grams. I'm given moles. So what needs to go on the bottom to figure out and cancel out the moles so I can get grams? That would be 1 mole. Because, again, 1 mole is equal to, okay, 1 mole is equal to the molar mass of whatever compound or element you're trying to find. Okay, so I have 1 mole of H2O. Okay, that is equal to my molar mass, which is 18.02 grams of H2O. Okay, I will now, can cancel out moles, cancel out moles. So now I'm going to solve. So I'm multiplying now on top. So I have 1.34 times 18.02. I'm going to write exactly what I have. 24.1468 grams. Now, I have 1.34 was my given, and that has 3 sig figs. Well, this doesn't have 3 sig figs, so I need to get it to 3 sig figs. So, what I'll do there is, I have 24.1 grams of H2O. Alright, here we go. Moving on to our next example. We have how many moles, again, that's what we're trying to find, are there in 65 grams, that's our given, of carbon dioxide. Okay? So, carbon dioxide we know is covalent. Okay? If we know and remember our naming for covalent is we use prefixes. carbon right here, we just have one of them. We don't use mono, okay, because we know since there's just one carbon that that's all it would be, so it would just be C. Di equals 2, and then oxide meaning oxygen, so it's CO2. Alright, now let's do and find our molar mass. So we have 1 carbon, we have 2 oxygen, and we know we find these values on our periodic table. Okay, 16 times 2, 32. Add these up, and we get 44.01 grams. So we have our molar mass. Okay, now we can start doing our dimensional analysis. And just a reminder, okay, we have moles, or not moles, we have our grams, so we're trying to get to moles, so we have to use that molar mass. So I'm going to start with my given, which is 65.0 grams of CO2. I'm going to draw my train track. I have a gram value up here, so I have to have grams down here in order to cancel that out. So I'm going to put my molar mass of carbon dioxide, which is 44.01 grams of CO2. And we remember from what I said last time is 1 mole is equal to that molar mass. So up top, I'm just going to put 1 mole of CO2. The value I'm trying to get is moles, and we have moles up here at the top, so I can cancel out my values of grams, and now I can just plug that into my calculator. I'm going to divide this time, so I'm going to do 65.0 divided by 44.01, okay, and I'm going to write exactly what I see on my calculator, which is 1.4769, okay. Now, 65.0 tells me I need 3 sig figs, okay? That's not 3 sig figs, so I would need 2, okay? So I have 1.4, which is 2 sig figs. This 6 right here is going to make me round that up, so 1.48 moles of CO2. Alright, and let's do this last example problem together. Okay, this time we're trying to find how many grams of sodium chloride are in 7.50 moles of sodium chloride. Okay, so sodium chloride. We look at this, okay, we know it's not covalent. Okay, so sodium on our periodic table, and again, we know what element is what because it gives us the name. So sodium, which is Na, with a +1 charge, chloride, which we know is chlorine, okay, has a charge of -1. When we swap those, okay, they cancel out, so we're just left with NaCl, okay. So our molar mass, okay, I just have 1 sodium, and the atomic mass for that is 22.99, so for chlorine, I just have 1 again, and that is going to be an atomic mass of 35.45. Okay, when I add these up, I get 58.44 grams. Okay, so that is our molar mass, okay? So now I'm going to take my given, okay, which is 7.50 moles of NaCl, okay? Going to draw my train track. We have moles up top, so we need to have moles on the bottom to cancel. We know that 1 mole of NaCl is equal to my molar mass, which is 58.44 grams of NaCl, okay? Can now cancel out my moles, and I will solve now. So I will do 7.50 times 58.44. I get 438.3 grams, okay? We need 3 sig figs. So my answer would just be 438 grams of NaCl. Okay? Now, the steps that I just went through with you, that's what needs to happen every time you do these. We give you these tables for a reason. It's really helpful whenever you are solving everything so you don't forget a step. Now you have some practice problems. So you have 1, 2, 3, 4 practice problems that you'll need to complete. Okay, you'll need to make sure that you show all of your work for it. And like I mentioned, make sure that you have this drawn because it is going to be really helpful and beneficial for you whenever you forget what step you need to take in order to solve for what you're solving for. But yeah, thank you guys.